Hello, everyone. I'm Yamin Tian from Endgame. I'm a kernel developer, and today I get to do an introduction to Windows kernel debugging. So let me share my slides. For those of you new to kernel debugging, you probably already collected a bunch of books and online materials. And yet still, you might feel like standing in front of a huge, giant, mysterious door built by elves, and the door is asking you for a password to enter. And don't worry, I get you. I can remember like 10 years ago when I get my first kernel assignment. Back then, I had any kernel developing or kernel debugging experience. And out of blue, I received a ticket with a Bluescreen, aka BSOD dump. It's also a kernel crash dump attached to the ticket. And it says, the ticket says it's from a customer side, and the customer is running our software and it crashed. So I was like, I was really scary back then. I thought, oh, I need to go back to college. But now when I look back, there's no need to panic. And I think as long as you have some C programming background and you have some understanding of operating system, anybody can enter the door. So let me show you my agenda. You need some tools. First of all, you need to get over your fears, and then you need some tools. So here I recommend Windbg, which is the best kernel debugger of all. And then you need to know several things: load symbols, how to load symbols, and then how to collect BSOD dumps, and then know how to configure Life Kernel Debugging with VMware. With that said, it's like a quick start to get your hands on it. I'm not encouraging you to take any shortcut, because kernel debugging is really a science. There's a lot of background knowledge in it. It cannot be mastered in over one night. So the point I'm trying to make is that if, as a beginner, today you are able to remove one small piece of rock that's blocking your way, and you keep doing it day by day, month by month, years by years, and then years later, you will be able to move the mountain. So that's my point. And to be able to help you get inside of the door, I'm gonna show you 3 most common problems of kernel mode software. And I'm gonna also show you my debugging, my approach to how to debug them, and then finally I'm gonna talk a little bit about how to fix them. So if you are those who's already inside the door, you might find that my approach might be a little bit different from yours, maybe totally different from yours, and that's totally fine too, because there is no universal way to debug, and sometimes it can be a little bit personal, and that's totally fine. For those of you who's already inside the door, this talk is like an exchange of ideas. So let me get started. First of all, how to load symbols. I'm not sure if you are able to see it in the back row, but don't worry. So if you miss any details, or if you are not able to see clearly, I have a blog post and it's in the end of this PPT. I also share the blog post. And if you have time, you can read the article, the blog post offline. So here I just go over quickly that how to configure the symbols. Basically, you pass this string, symbol string, started as RB, the string into that Windbg window. It's a symbol path window. Copy paste into it, and then reload, check reload on the lower left corner, and then click OK. And then in case if you have your own symbol server, you also need to tell Windbg your own Windows server path. Here's an example. And also another case is if you don't have a symbol server, you can download symbol of your driver to your local host and then configure Windbg to understand the path of your symbol, just like that. So here you go. Remember I mentioned that my first BSOD really scares me, but what I just talked about was really all I need to figure out my first blue screen. So this is the symptom of my first blue screen, and I'm able to recreate it, right? I'm able to write my own new sample and recreate the same problem. I remember it very well. And let's look at how I figure out the problem. So in Windbg, I loaded a symbol, just like I mentioned before. And then just like magic, Windbg is able to point you to the problem area. It's pointed by the red arrow. The red arrow already points you at the problem, the crashing location of my source code. And let's look at the source code. If you are not able to see it clearly, the source code is also in my blog post. You can find them at the end of my blog post, which I have linked to this presentation. So you can see that matching what the debugger information with the source code, you can immediately figure out what's wrong with your source code and then fix it. And that's all I need to figure out my first blue screen. And it doesn't require any special kernel knowledge, right? So that's how I get started. Next thing we need to know is how to collect BSOD dumps. All the detailed steps is also in my blog post. In case if you are not able to see the windows here, basically you go to the target system you are about to debug, and then configure the startup and the recovery settings there. And in that drop-down list, you choose kernel memory dump. Third thing is how to configure live kernel debugging with VMware. So this figure shows the basic component of live kernel debugging with VMware. Basically, 3 components. You got a host machine, and then you have a VMware. Inside of VMware, you have your target Windows system running. And then you have a Windbg debugger connected to your target through a pipe. We need to configure the 3 locations, the 3 pieces of them separately. In the host OS, we create a virtual device. We create a virtual serial device based on pipe. And then inside VMware, inside the target Windows OS, we configure the kernel debugging session. Again, the detail step is not shown in this figure, but you can find the detail step in my blog post. So here I just get you familiar with the thing, the steps, and then I will go quickly to my to describe my approach to the common software problems instead of describing the detailed steps here, because the detailed steps it's hard to memorize. And if I work on a specific problem, I can remember each command I use. I use it every day, and I'm very familiar with them. But if I go on vacation, after 2 weeks, I forgot all of them. So what's the point to make people memorize all the detailed steps and the commands you're using? They're destined to be forgotten, right? So here in the talk, I'm trying to describe the general approach to the 3 kind of problems. I don't require you to memorize specific commands, because once you have these general ideas about how to approach them, you can just look up online and find your own tools or commands to use. So let's move forward. The first general problem, the common problem, is 100% CPU. So 100% CPU in the kernel might sound very scary to you, but for me, it's really the most simplest problem of all. So that's why I listed it first. It's easy to troubleshoot and easy to fix. But to begin with, it's a little bit complicated to figure out there is such a problem. There is a 100% CPU problem, because sometimes it may not be so straightforward to identify it. Why? Let's take a look at the CPU chart. This chart looks straightforward. It's 100% CPU. I use the Windows Task Manager that comes with every Windows. So you can easily run this tool and figure out, oh, there is a 100% CPU. I enable the kernel time, so it's shown in red. So it means the kernel is taking 100% CPU. So this one is a straightforward example. The next one is also straightforward. I have my computer has 2 cores, 2 CPU core. On each of them, I got 100% CPU. So that's also straightforward. But what if, for this case, it's not shown as 100%? To demonstrate this case, I wrote a sample code. The sample code has one thread that's running in a loop, and one thread is taking the 100% CPU usage. But because I only have one thread looping, the CPU usage of that one thread is being distributed onto 2 cores. So averagely, you don't see 100, you only see 50% of CPU usage. So that's a little bit not straightforward. And then let's look at this case. This case, my computer has 8 cores. So I have one looping thread. The thread is looping forever. It's taking 100% CPU, but that thread is spread onto 8 cores. So average speaking, the CPU usage is pretty low. It's only taking like around 12% of the overall CPU usage. So to identify, that's the little complications that it's a little hard to identify. There is such 100% CPU problem. But to identify the problem, it's preferred if you have one core system, run your program on one core system, so the 100% CPU problem will stand out. If not possible, there's other indicators. So let's take a look at that 8-core CPU graph. Normally speaking, if your software system is in good health, the CPU usage will be evenly spread to different cores. But in this graph, you can see it's not even. Some of the cores has really spiked high CPUs, but the other of them has really low CPUs. That means problem. So in a healthy system, if you get your system load gets higher, your average CPU will get higher together on each cores, not like spike in one of them or some of them too high and some of them too low. So the uneven CPU distribution is an indicator of the CPU problems in your software. So now we're able to identify that a 100% CPU problem is happening. So let's go to the next step, how to troubleshoot them. The keyword is snapshot. The snapshot is a memory, the target system memory, while the high CPU usage is happening. It can be a kernel memory dump, and it can be a live kernel debugging session at real time. And then in the snapshot, you examine all the costax. So that's the general approach. I can take you through the example that I created. My example has a 100% CPU problem. So I just go through this example really quickly because the detailed content is online in the blog post. I connect Windbg debugger and break into it to get a snapshot. And then I get the call stack of my driver. The call stack is already pointing at my code, which is looping. So once you get the call stacks, it can show you the location your code is looping. That's how powerful this debugger is. And it's also telling you that 100% CPU problem is not scary at all. So let's go back to the code. Because just now, the debugger already pointed out the code location. So by matching that information with the real code, we can see there is an infinity loop there in the code. So this code is just a demonstration. To fix it, fixing is not universal. To fix a 100% CPU problem, you need to really know your code logic really well and choose the fix based on your needs. For example, you need to set a break condition to jump out of loops and consider yielding CPU by calling APIs such as sleep 0. So for time's sake, I'm gonna go quickly to the next example. Next common problem is deadlock. Deadlock usually involves two entities. Typically it's two threads and two different resources. Like thread A already acquired resource A, but it's waiting on resource B. And then the other thread B, already acquired resource B and is waiting on resource A. So they form up a circle and nobody can get out of this circle. Therefore, nobody moving forward. So that's the typical deadlock. How to debug deadlock? First of all, most important, it's call stacks. First, you get the costax, and then find out the lock information on your system to figure out which lock is already held by which thread. I also created a sample code that has a typical deadlock in it. So I'm demonstrating how I debug the deadlock problem in my sample code. So this is the costax, just like I just mentioned, that the debugger is able to figure out the current status of all of your threads. And you can see that the two red arrows, they're pointing at codes that never move forward. So that's the first step of getting costax. Next step is getting lock information. Here, I recommend using the command ban locks. This command can help you get the lock information, like which lock is held by which thread. Again, I'm not sure if everyone can see it clearly. So this information already indicated that lock A is acquired by my thread A, and lock B is already acquired by thread B, and each thread is waiting on the other lock. So combining the two informations indicated by the debugger, we can go ahead and match the location in the source code. So in that source code, as the red arrow points out, that's the location where nobody's moving forward. Now we figure out the problem location in source. Let's proceed to fix. Again, for a developer, fix is not universal. That the developer really needs to know where your code is going. I can only provide some general suggestions. Number one is I try to avoid using nested locks. Like after holding lock A, acquire lock B, and while holding the locks, I try to acquire lock C. So that's nested and make the coding scenario really, really complicated, and eventually it's easy to get locked. Another thing is always acquire locks in the same order. So in case you really need to acquire two locks, always acquire in the same order. Getting lock A first and then getting lock B. Do not, in any circumstances, having different order. Like one doing A and B, the other doing B and A. That's the recipe for deadlock. And inside the lock, try to avoid lengthy operations and try to avoid API calls. What I'm going to avoid here is to avoid issuing new I/O to the lower driver when I'm holding a lock, because that's also disaster recipe. In a lock region, try not to create new I/O. So that's one of the rules. So that's about deadlock. So let me proceed to the third common problem, which is Bluescreen. Bluescreen is really complicated problem because behind each Bluescreen, the reason can be different. Even the ones having the same symptom, but the reason can be still different. For the time's sake, I'm gonna only cover one most common type of Bluescreen. As you can see the bug check number there, I can read to you. IRQ or URL, some people call it URL, not less or equal. So that's one of the most common symptoms of Bluescreen. I created a sample driver that's causing this kind of bug check Bluescreen. And using your debugger, start with the command ban analyze -v. That's a very useful command. You can use it pretty much for every crash dumps. Sometimes by running the command, you can already figure out the problem. For example, in my case, the red line already pointing at the crashing location in my source code. And I go back to source code and find out the problem with the line of the code with the problem. Finally, we need to understand why in that example why it is a problem. And to understand this one, we need to have some kernel-specific background, some core concepts to master this science. Because kernel is different from the user land. It has some unique rules and conditions. This sample code, it crashed there, the crash location at line 63. It violates some kernel rules. I listed here. It's accessing page pool inside a spin lock, so forth. And the other reason is on the inside the spin lock, the URL level is inappropriate for this kind of memory operation. So if you are new to this kind of thing, if you are new to Windows debugging, you might not be familiar with the concepts, but I have the links in this blog, in this PPT. So I also provide the information in my blog post. You can get it from the presentation. Finally, it's the fix. Try to access page pool and non-page pool at the right URL level. And sometimes you need to access usable memory from kernel. Try to protect the memory access with the try exception block, and always synchronize your threads. So that's pretty much, that's all my 3 examples of the common kernel problems. And finally, you need to get your hands on it as soon as possible, because kernel debugging is a very practical science and it's a lot of fun. So hopefully my talk, it's not covering a lot, but it covers a lot of things I wish I had when I first started 10 years ago. So hope it helps, and thank you very much. I share my blog post link here, and hopefully I have some time for some questions.
Thank you for the presentation. That was really cool. I used to do kernel debugging back when it was DOS, so it's good to come up to date. What made you get into this? Are you a kernel architect or related to folks that write Windows kernels? Or what led you to debugging at the kernel level?
I didn't really hear very clearly. So
what led you to debugging at the kernel level? Do you work with kernel architects? Are you a kernel writer?
I'm a kernel developer, and kernel debugging is a part of kernel development. It's always together. You have developing and then you have debugging. They always come together. Debugging is not avoidable. So debugging is the means to create correct and efficient software. So that's why I do it.
Do we have any more questions in the audience?
This is kind of a general thing, but given that RSA security is next door and that, do you have any thoughts on security aspects of your work? How it can be useful to deal with rootkits or anything like that?
Oh,
It may be too big a question, I don't know. But
yeah, it's a 30 minutes talk. I know I'm not able to cover a lot because kernel debugging is really a huge and a vast topic. So today I'm just trying to make some topic. Initially, when I planned this talk, I did plan to add an example of analyzing rootkit. But then when I did that rehearsal run, and then it involves some kernel-specific concepts, and then people suggest me to just cut it because it takes a long time to explain each. But if you are interested, I can follow up. I can be reached through email. I'm around. I can talk to you.
That's all the time we have for questions. Let's thank our speaker again.
Thank you.